So, 2, does that do anything? It's just a constant. So we just go 2 times. We're now going to look at deriving inverse cos. Let's go through slowly. Inverse cos is going to be negative 1 over square root a squared minus whatever I've got written on top squared. Yep. Oh, hang on, I called it something fancy. I'm going to multiply by the derivative. 6x. Negative 12x over root 25 minus 3x squared plus 1 all squared.
What's the domain?
What about the domain?
Is it like negative 16 and
So it's negative 2 root 3 to 2 root 3.
How did you tackle that?
Let the denominator, because that's the function that you're concerned about, let it equal 0 and find the value correct for that.
Okay. So what did you end up with?
Negative 2 root 3 to 2 root 3.
Negative 2 root 3. Negative 2 root 3
2.
to positive 2 root 3.
Oh, right, root.
No, 2 root 2, sorry. 2 root 2.
This has to be between negative 5 and 5. Yeah?
Minus 2.
So take away 1 from both sides.
Minus 2x squared.
Divide both sides by 3. Then what? Then what? Yeah, that's what I asked.
So is it like plus minus both?
So you square root both sides, but this side, negative 2, you can't square root. Yeah, so that's an irrelevant one. But what you're saying is that x squared has to be less than 4 over 3. Hmm? Yeah, confident with that?
2 root 3.
Which is the same as saying this, which if you picture, that's a parabola goes bang bang, and those intercepts are the square root of 4 on 3, which is 2 over root 3 and negative 2 on root 3. Or 2 root 3 on 3. Did you have the 3?
Maybe I didn't screw it up.
Because you said 2 root 3, yeah, but you didn't have, so it should be, or you can actually write the magnitude of x is less than 2 root 3 on 3. It's the same thing. Basically, in there, that'll make this function exist. So the domain is probably the hardest part. Two new ones, 2 difficult ones. But we go back, as always, first principle. Happy? Don't like the root x, I'm going to go x to the power of a half. This involves a bit more algebra, so we'll go through it slowly. dy dx equals the derivative of inverse sine. First of all, what is a? 1. Yeah? A is in the form x over a, so there is no 1 on the bottom line. A is 1. So 1 over root 1 squared minus whatever I've got, which is x to the half squared. You'll end up shortcutting these, but for now, yeah, so whatever's in there comes in here. Then multiplied by the derivative of that, half x to the negative half. Yep. Tidy time. 1 over, okay. This is root 1 minus x to the half squared. X. 1 over 2. The 2 goes down to the bottom. Right? Because that half, really, that 2 is on the denominator. And this x to the negative a half, I can bring on the bottom and make it root x. Are we happy with that? X to the negative half down to the bottom line to make it positive. 2 down to the bottom line. And you've got the answer 1 over 2 root x minus x squared. That's my derivative. I like doing this just for fun. Let's do this method for domain. Negative 1 less than root x less than 1.
Doesn't change.
True? Negative 1 and 1 normal, stick that in. How do you get rid of root x? Square it. Square both sides. That's okay, yeah? Good domain. X is between 1 and 1, but not allowed to equal 1.
So root slash 1.
Is there an issue with that?
There's
Does
no
anyone have a
such
problem with
number.
that? It's between 1 and 1, but it's not allowed to equal 1.
There's no such number.
There's no such number. Right? There's no such number. You can't be between 1 and 1 but not be 1. So this is crap. Mathematically the way we derived it, right? Because inequalities don't like square roots. You know how there's rules in inequalities? If I divide both sides by a negative number, I change the sign. If I multiply by a negative number, I change the sign. What the hell do I do if I need to square? I don't know. Because it depends on the magnitude of the number in the first place. Okay? So there's no rule. So we're not going to go that way. We hit a brick wall. We're going to go back to logic. First principle. What's the domain of this function? You haven't got a calculator and you have to give me the domain.
It's between
Are you allowed to answer that, Shireen? You come back into the table. You're welcome back to the family. What's the answer? Negative 1 to 1?
Excluding 0.
Negative 1 to 1 excluding 0. So negative 1 to 1 excluding 0.
We're looking for the domain of the type. For the function specifically or sign.
No, we want, for the derivative, what's the domain of this function?
It'll be
It should be negative infinity to 0 and 1 to infinity.
no other way around. Negative infinity.
Negative infinity to 0. So negative 5 is allowed.
No.
So if I put negative 5 in here, and I take away negative 5 squared,
It's
It's
already,
negative infinity to 1.
yeah,
And then 0
0
to
to
infinity.
yeah.
so I can put 10 in. True? 10 minus 100. Bum bum. Can you put a half in? You're the guys who've got the problem with domains. Go and think. How do you check? Your first point, how do you check? You sub in. What other strategies do we have?
Oh, it's 0 between 1 to 0, excluding 0 and 1.
So 0 less than x, is this what you're saying?
Yeah.
Yes?
It just keeps saying.
Do we agree?
No. It's
Strategies.
No, it's only 0 and 1.
It's only 0 and 1.
Yeah.
So it's 0, comma 1. No numbers in between.
No, it's only 1. It's only 1. It's only 1. Yeah.
I'm back, Filio.
No, that was a joke.
I put my money on him at the moment. It's negative. But how? How did you get it?
You make square root of x, take away x squared, have to not, cannot equal 0.
Okay?
And then,
So, yeah. x minus x squared cannot equal 0.
Square root of whatever.
So then what did you do?
And then you put in numbers in.
You put in numbers. Okay, that's a strategy.
Yeah, you draw a graph. And
Draw a graph.
And then see which one is below x.
Can you picture that?
No. You can.
It's parabola, upside down parabola. What is the x-intercepts?
0 and 1.
0 and 1. 0, 1. Now you're saying it doesn't equal 0, so that means it can't be 0 and 1. But what else? What does this have to be? Greater than 0. Anybody here is greater than 0. 0 less than x, less than 1. Or, alternatively, can you look at those two functions? When does that exist?
Every value. Every value apart from 0. 0 to infinity.
All positive values.
Every value but 0, 0 to infinity. That's 3 different cases. Pick bloody one. 0, thank you. Good. Infinity, oh good, because I was going to really try hard to make it. Far out. X is bigger than 0, yeah? Is that a simple way to say it? What about this? What about 1 minus x? When does that exist? X is?
Less than 1.
X is less than?
Less than including 1.
Yeah, but it's on the bottom line, so we'll say x is less than 1, yeah? So, one function says I exist for x is less than 1. The other function says I exist for x is greater than 0. The only two times that we're both happy is between 0 and 1. Have you not done f of x times g of x in methods? F of x plus g of x, f of x times g of x. What's the domain of a multiple function? It's the intersection of the two functions. I work from there to there, you work from here to here. We can only work together in this zone. That's the common domain. Right? So there's a variety of ways out. As Philia said, solving, graphing, looking at two. So that's why I took those two stages separately. It's easier to see there, it's not as easy to see here. Okay? Calculus is the fun part, the domain sometimes can be a bit of a hassle. But at least with you. Last one. What's A? What's A? A is x. Can A be x? What's A in our rules?
Denominator.
Yes.
It's a constant.
It's a constant. Yeah? A is a constant. The definition is x, which is the variable, over A, which is constant. What's the value of A?
1 on 5.
Happy with that line? Because I want my x on top. My rule is x over A. Don't confuse me and put the x on the bottom. Put my x on top. Who's on the bottom? 1. Therefore the question is, what's the value of A? And the answer is 1. So dy dx is -1, because that's what cos does, over A squared minus my function squared. Yep, because you're replacing it with an x. Sorry, John. And then multiplied by the derivative. Negative 5x to the negative 2. Good? That's calculus. Just like in methods. There's the rule part of it, and then there's the algebra part of it. The rule, everyone goes, oh, calculus, calculus. Calculus is piss easy. It's the algebra that screws people up. So we now need to tidy. First things first, I don't like this looking like this, so I'm going to write negative 5 over x squared. Under the square root, I'm going to write 1 minus 5 squared, which is 25, over x squared. And just yell as soon as you think, what's he doing? No, yell means you're happy.
So what happened to the 2?
What happened to the 2? I'm mistaken, I forgot. Thank you. So 2 times that function, yeah? So let's go with 2 times that function. Thanks. Okay. So 2, negative 1, negative 5. So we have got 10 sitting on the top line. See this root thing? Let's fix it up. That's x squared minus 25 over x squared. Because it's lowest common denominator, basically. I've tidied that fraction up. 1 over 1, cross multiply. Times, there's an x squared still sitting here. Don't need the 1, just make that line 1. Okay, so you've got your 10 on top. I fixed this fraction up, and I've got times this x squared sitting there.
Can you pull out the x, 1 on x squared?
I will. Yes. Yep, that's good. So we're happy with that. And now, as you said, you've got 10. Really, this whole root thing, I'll go slowly because people don't see this often, that's the same as writing that. Yeah? Root, and then you've got a little x squared sitting there. But the square root of x squared is x, and the x can cancel with the x squared. So really, you should tell me that the final answer is that. X squared becomes a square root of that is x, cancel with the x squared, leaves me just an x. And that's floating around. And now, the domain.
Same
Same?
thing. Same thing.
So what's the domain?
Negative.
Between negative 5 and 5?
Negative infinity to negative 5 and 5 to negative 5 to 6.
Which way?
This is a recorded yeah. Yes?
Between negative 1 over 5 and 1 over 5.
Okay. So 0 is good?
No.
No, because this guy's going to mess you up with 0, yeah?
So it's like...
And if you did 1 over 5, square that,
Yeah.
is 1 over 25.
Yeah.
Take away 25.
So it's
It's negative. So,
Negative infinity to negative 5 and 5.
yes, well done. You have to get one right eventually, yeah? No. X, do you know this function? X squared minus 25. What's it look like?
Half circle.
No, not half circle. The wings. Fly, the phoenix. Have you not done that?
Modulus.
Boom. Boom. This is a squared minus x squared. Semicircle. This is x squared minus a squared. Yeah, hang on. Hang on.
So do we have a meeting today?
Yes.
Yeah.
Give me a couple of minutes. Right. X squared minus a squared is wings. You're going to have to be bigger than 25. 26, 30, 47. That's all good. So this is x is greater than 5, union x is less than negative 5. 6, 7, 8. Square it, take away 25, I'm positive. Negative 6, negative 7, negative 8. Square it, take away 25, I'm positive.
So can you do it with that